Hello, this is a video for a Chapter 9 test review. Our first situation is called third situation. It is reported that the average weight of all newborns is 7.5 pounds. Here is a sample of 15 newborns in pounds. We have the data provided 8, 9, 9.5, 8.25, 9.5, 10, 8.3, 9.4, 7, 8.2, 8.6, 9.1, 7.9, 8.2, and 9.2. And is there enough evidence at the 1% level that the average weight of a newborn is greater than 7.5 pounds? So we're going to write down what's given. And what's given is that the average, the claim mu equals 7.5. To find the sample average, we're going to take that data and put it into the calculator. So I've taken the data and I've pressed stat, number 1 for edit, and I've placed all that data in list 1. So place the data in list 1. Now if I want to find the sample average, I'm going to press second mode. I'm going to press stat, to the right for calculate, choose number 1 for one variable statistics, choose list 1 by hitting second 1, and push enter, or go down to calculate, push enter, and you notice that X bar is 8.676666666667, and our standard deviation is 0.7948. So we know that X bar, I'm going to round to 8.68, N is 15, there are 15 samples, and our alpha this time is 0.01. So for our HO and HA, we're dealing with numbers. We're not dealing with proportions in this case. So we use mu equals 7.5. The average weight of newborns is equal to 7.5. That's the claim. And HA is going to be mu greater than 7.5, because in the problem we're asking for greater than 7.5. So HA would be mu greater than 7.5. The average weight of newborns is greater than 7.5 pounds. Next, we're going to check our conditions, and there are 3 conditions. This will be a t-test because we're dealing with numbers and we have one group of data. So condition 1, random, and that's stated in the problem, which should have been stated. Condition 2 is normal, so we can make a histogram to see if the data is about normal, which is about normal. But remember, if we're doing a t-test, if you have more than 30 samples, then you're fine. We have under 30, so we have to check if it's normal, so it's about normal. And then condition 3, your population has to be greater than 10 times the sample size. Our population is all newborns. That is greater than 10 times 15, which is 150. Yes, there are more than 150 newborns. Then we go into our work. So to do the work by hand, let's make sure we know what's given. Mu is 7.5, X bar is 8.68. Our standard deviation, which we got from the data in the calculator, is 0.795, N is 15. First step to do it by hand is we need to find the SE. To find the SE, you take your sample standard deviation divided by the square root of N. So 0.795 divided by the square root of 15 equals 0.2053. Now we can find our test statistic, our t, which is X bar minus mu divided by your SE. So it's 8.68 minus 7.5 divided by 0.2053, which gives us a test statistic of 5.75. Now, we're going to get the p-value from the calculator, but if we look at the test statistic, notice that's a really large number. It's kind of going back to our standard deviations. And if we had a 5.75, that's way off the chart. That's way over to the side. It's very unusual to get such a high number. Now, we can get a critical value from the t-table. So if you go to a t-table, our degrees of freedom is 14. We get that by taking n minus 1. 15 minus 1 is 14, and 99%. So if we look at the t-table, we can find that the critical value is 2.98. There are different t-tables, so here's one example of a t-table. So since we're doing 99%, we look at the 1%. Our degrees of freedom is 14. That's where we get the 2.98 from. Okay, so if I was going to draw a picture, if we draw a normal curve, 5.75 would be way down here. We're looking for more than, so it'd be a very small area. And our critical value of 2.98 would be to the left of it. And then we're looking for greater than, so that area is larger and that's smaller. So our p-value would be that area. So the p-value for the 5.75 would be smaller than the area for the 2.98. So your p-value would be smaller. But we're going to find the p-value in the calculator. So we go to the calculator. Remember, we have our data stat 1 for edit. We have our data in list 1. And we're going to do a t-test. So I'm going to hit second mode. I'm going to go to stat, to the right for t-test. Push enter. This time we have the data, but we could also do stats. But since we have the data, we're going to choose data. Our mu is 7.5. The list of our data is in list 1, so we hit second 1. Frequency, we always leave it at 1. In this case, we're doing greater than, so we choose greater than. Then you can choose calculate if you want just the numbers, or draw if you want the picture and the numbers. So if we did the draw, hit enter, we find that our test statistic is 5.73, which matches pretty closely to our 5.75, and our p-value is essentially 0. If you want to know the exact p-value, you go to stat, over to test, choose t-test, and then we choose calculate versus draw, and you can find your exact p-value. It says p equals 2.585, but be careful, it's not 2.585. At the end of it, there's an e to the negative 5. That means you have to take the decimal, move it 5 places to the left, so you'd have 0.0000258. Essentially, our p-value is very small, very small. So, since our p-value is very small, we compare it to our alpha of 0.01. Our p-value is smaller than alpha, therefore we reject HO. There is statistically significant evidence to reject HO, and we conclude the average weight of newborns is greater than 7.5 pounds. Now, for the confidence interval, we passed our conditions. The formula for the confidence interval for a t interval would be x bar plus or minus t star. T star is what we got from the t table, times your SE. So it would be 8.68 plus or minus that t star, which we got from the table, 2.98, and then times your SE, which we solved earlier. We do 1 minus 1 plus, and we get 8.0683, and then 1 minus 9.2917. So we can say we are 99% confident the average weight of newborns is between 0.087 and 9.29 pounds. Notice this verifies our conclusion. We said that it is greater than 7.5, and when we do the confidence interval, our entire interval, 8.07 to 9.29 pounds, is greater than 7.5. Below that, you have the step-by-step for the calculator that we just reviewed, and that is how to do a t-test. T-test. Thank you.